Alright, enough talk about furnaces and ductwork and heating. Let's do a good old-fashioned unboxing video. It's been a while since I did one. Pretty sure I know what's in this box, except the box is like twice as big and heavier than I anticipated. So, I'm a little curious, is this not... what I think this is I've never seen in person. But I've seen videos, I've seen photos, and it didn't seem this big to me. So, well, I'm going to grab a tripod and a box cutter, and let's take a look. Let's see. Well, looks like there's a bunch of styrofoam after the cardboard. Okay, yeah, it looks like they just dropped this into the styrofoam and it is solidly wedged in. I don't think I have any choice but to break off the side on the styrofoam. I hope it didn't damage anything. You can see as that slid down, the handle on the cabinet skated it and then wedged in here really tight. That's why I couldn't get it out. Now we can get it out. Almost. And the handle's stuck on the other side. Okay. So it's not, it is about the same, it is about the size I thought it was. It was just a heck of a lot of packing and padding. Alright. So what is it? It is a CRT tester and rejuvenator and has some repair features. At the time this came out, I'm sure it was top of the line. It certainly has more features than any other device I've seen. It is pretty ancient though, so something like a Suncor CR70 or CR7000 even more so, may not have all of these functions, but I think what it does have works better than something like this would. For example, this is pre-color. I looked around online and found a version of a manual that's pretty close to the device I have. There's no cover on it. The very first page is the schematic. Not crazy about it, but we'll go through it quickly. I'm not crazy about it because they don't put component values on it, and it's a little hard to follow some of the functionality. Upper left is a Wheatstone bridge. As you can see, a 6SQ7 triode to check for leakage between elements. Shorts. It's a short test, essentially. It's supposed to have a 20 mega ohm sensitivity. Upper right is another 6SQ7 triode, which checks for continuity to make sure that, like, your filament is intact. Bottom left, power supply. The thing that jumped out to me was the first secondary winding at the top of the transformer, or the transformer T1, I should say, is 1800 volts. And they have a 2x2 high voltage rectifier tube, some filtering, and you get plus 2500 volts DC brute force out of it. Unlike a flyback, which is inherently current limiting, this probably has a pretty good punch. There is a current limiting resistor R27. If that's got a really large value, it may help, but I would definitely not want to come anywhere near the output of this. Below that, there are two other transformers for filament windings. And below that, it's really hard to follow this, but there are the 4 selenium rectifiers and 4 electrolytic capacitors directly across the line, forming a voltage quadrupler to provide the B+ voltages for this device. The rest of the schematic is basically all the rotary switches and push buttons and relay contacts for all the functionality. Not the easiest thing to follow by any means. I've already jumped ahead and looked through the manual. It's a little confusing to read. because it looks like it's kind of like a scrapbook. Like maybe this has been through a few revisions and they've kind of copied and pasted it, and some of the fonts change and the text doesn't flow that well, but I think I've got the gist of it. This page on the left side, they have a troubleshooting guide. They don't have a calibration procedure, unfortunately. They don't have any procedure to check that it's functioning correctly, but they do list a bunch of potential problems you might have and what might be causing them, so at least that's something. Right side, we got a parts list. That's why I knew that those 4 caps were 30 microfarad DC electrolytic caps. There are no plus signs on the schematic. There's no curved line. There's nothing to indicate the polarity of those caps in the schematic. It's another thing I really don't like about it. So I'll have to be very careful when I replace them. Okay, as far as the functionality goes, the continuity function is kind of interesting. They actually call it a mutual transconductance test. And they check that you have continuity with the cathode, the grid, and the first anode. They also talk about ways to test the second anode. Now that's the high voltage button on near the front of the CRT. I didn't take a good enough look, but maybe there is a connection from this device that goes to that. It says to test the second anode, there must be enough emission to light the neon lamp. So yeah, so that's one very distinguishing feature of this versus other picture tube testers is this puts voltage on A2. This puts out of several thousand volts. I've never seen any other tester that put any voltage on the second anode, and even on the first anode, they only put a few hundred volts. They don't put several thousand volts. So it's probably enough to actually light up a spot on the face of the CRT, certainly on a strong CRT. And they say you have to have the ion trap in place, both to check the second anode, but I think you could actually damage the internal electron gun if you don't have it in place, because the electron beam could strike a metal surface inside and actually burn through it. The shorts test is conventional, just like a shorts test in the tube tester. They check that there's infinite resistance essentially between elements. Emissions test, that's your standard emissions type test. They say if you got 400 microamps or better, it's probably good enough and don't bother testing any further. For the grid cutoff, they say if it's between, I think, about 30 and 60, it's probably okay. So that's a curious thing about this. There is no tube setup chart. There's no list of supported picture tube types. They assume that you've got a 12-pin standard picture tube, 6.3 volt filament between pins 1 and 12, grid on pin 2, potentially a focus grid on pin 6, first anode on pin 10, and cathode on pin 11. If you don't, you probably have to make your own custom adapter. They give a nice little explanation here with a blow-up of how an electron gun is assembled, which you kind of need to know to get the full use out of this. Some of the things it can do are kind of wild. I was a little bit wrong about the high-frequency coil. Yes, you do use it for removing shorts, but you can also use it to see if there's gas in the tube. Just like you may know if you have a Tesla coil and you bring a fluorescent lamp near it, or a neon bulb, it'll glow. Same idea with this. You bring high frequency, high voltage near your CRT and see if it glows purple or blue inside, or a reddish purple cloud. If you get that means you get gas in your tube. For restoring it, the cathode sweeper, the super sweeper, the booster, that's all standard rejuvenation stuff where it boosts the filament voltage, and it charges up a cap, and it discharges it between, I think, the cathode and the grid or something like that. Or sorry, Yeah, I think between the cathode and the grid, the idea is to expose from some fresh coating on the cathode sleeve. And they do warn you, as I have many times before, every time you try rejuvenation, you are removing some material from the cathode to expose fresh surface. There's only so much material. At some point, you're going to actually start losing emissions because you're getting down to bare metal. You're losing the coating. So use it sparingly. Now, another wild thing this can do is kind of as a last-ditch effort, if we go back to that diagram. So in the middle here, we've got our heater, which is a little coil heater wire. There's a metal sleeve over that. That's your cathode. And over that is like a little metal can with a hole in one end, an aperture. That's your control grid. And the electron beam comes out of that little hole. Well, by applying certain voltages and currents, they have a mode where you can direct the electron beam against the control grid and start burning it away to enlarge that opening to let more electrons through. I've never seen that before. It seems to me you're also going to be putting vaporized metal inside the electron gun, which could potentially cause some problems. So I wonder how effective that actually is. And then there's welding the cathode. I've done this myself in the past with a different device. Idea being, well, they say you put an instantaneous pulse of about 20 amps to try to weld the filament back together. So what happens is the heater, the filament, it's a coiled bit of resistance wire. It can break open, just like a light bulb. Well, if you apply some voltage to the open ends, or charge up a cap and put it across the open ends, and then vibrate the neck of the CRT or give it a tap, and get those broken ends to make contact, you can weld them back together. In the past, I've just taken a screwdriver handle and tapped the neck, but they actually had a dedicated vibrator that you would place against the neck of the CRT, and it would shake it. I don't have it. I've never seen a photo of one. All I know is this little diagram they show here. It'd be cool to get. And that's the gist of it. So you can test for emissions, you can check for shorts, you can check for continuity, you can blow away shorts, you can try to re-weld an open element back together, and you can try to alter the size of the grid aperture to increase emissions. Pretty nifty. I will do my, well, let's say I will do my best. I will put some effort into getting this fully functional. I've already got working testers. I don't want to, this looks like it could be a lot of work. It's a neat device. Just for display, I think it's a really neat thing to have. Let's take a look at the insides of it, but I can't promise I will be actually restoring it anytime soon. I tried doing a little light cleaning on this, and I need to be really careful because this paint is not clear coated, and it's fairly easy to wipe off. I tried using some Windex and it started taking off some of the red pinstriping. So I think I just need to stick with water basically and use it sparingly. Also realized I'm missing one of the plastic bubbles. These are pretty standard size, though I don't think I'll have too much trouble finding one. There are plastic caps over the bulbs, and then behind them there are bulbs you can replace. Some are neon, some are incandescent. I'm missing the one over the cathode closer. So I believe the way you open this is you take the screws off the front. I noticed there were also screws on the bottom too, but it didn't look like the bottom. Well, the rest of it's like all just one piece of sheet metal bent around. This is the only part that actually comes off, so I'm sure you have to do this. It's slipping down. More screw left. Alright, there we go. Wow, there's a lot going on in here. So all the electronics are on a chassis that's what the screws are on the bottom that I saw. There's a selenium rectifiers, 2 on one side, 2 on the other. Some beefy relays. See one of the 6 SQ7s, that black metal tube up front. A couple giant relays, some transformers, a huge oil-filled filter cap. And then the back of this is just a crazy mess of wiring and switches, push buttons. Fairly nice wiring job. They laced the wiring harnesses. These are the connectors we saw in the schematic, I guess. I don't know if these come apart or not. I hope they do. It's phenolic. It's probably kind of brittle, so I'll have to be very careful with that. So, seleniums, that and that form a voltage quadrupler. You get giant relays. One here, one here. That is a big high voltage filter cap. It's a little precarious the way this front panel's balanced, but I'll try to show you the rest of it. So that large transformer in the middle there, that's the high voltage transformer. The 2 to the right of it, those are the filament transformers. That tube, that's the high voltage rectifier. And there's that high voltage filter cap. It's probably still good. That'd be a tough thing to replace. There's the other tube in the back corner. And I presume there's a bunch of parts underneath. That's as far as I'm going to take it right now. I got enough going on. I don't want to have more parts scattered all over. But hey, it looks to be in decent shape. It's all here. Assuming that the transformers are good. At least, you know, it'd be cool to get it working to the point where I can check them for emissions and shorts and stuff. I don't know that I would use some of those fancy exotic features like burning open the grid aperture, but at least for checking basic picture tubes. And the good thing for me is the vast majority of picture tubes I test are the kind that this was designed to test. Your standard 12-pin, 6.3 volt filament picture tube. I pulled out a picture tube of the type that this was designed to test. In this case, I think it's a 10BP4. You take the socket that comes out of the back of the tester and put it on the base. You need to have that ion trap magnet positioned correctly. And now I know what this was for. There's a high voltage insulated wire coming out of the back with an alligator clip on the end. That goes to the high voltage connector on the side of the CRT. And then there's an AC plug that plugs into the wall. Assuming I can get at least the basic functionality of this working, I think I'll set up a little table and a dedicated picture tube testing area in the workshop. Now, as far as the branding goes, I'm sure Raytronic made this. There is a company called Midwest that made radios, and this may be the same company. I don't know if it is, and if they were based in Detroit, Michigan. I need to do research on that. But it seems likely to me because I kind of remember that Lightning Bolt W logo. Now the picture tube happens to be resting on another box that just showed up. But rather than do 2 unboxings in one video, I'm going to break that off as a separate one. For now, I hope you enjoyed this look at a Midwest cathode beamer from the late 40s, early 50s, best as I can guesstimate.